no problem.
Okay. All right, it is now. So I will start from the top a little bit here. Okay, so when you first get the flight plan assigned to you, you want to go through a small little checklist. And you're going to notice that a lot of these things are some of the big things we've kind of been hitting on a lot lately, especially when we were talking about weather. But the big things that you need to know about the flight, first of all, right off of like within the first 20 to 30 minutes, this is what you need to figure out. First, is this flight legal to go? And what that means, and that's going to be a little bit of a mixture of things. It's going to be, okay, legal as far as weather is concerned, legal as far as MEL and mechanical issues are concerned, legal as far as alternates, which obviously kind of goes back to weather, but legal from that perspective. So the first thing you need, very first thing in your head that you need to think about is legality. Okay, the legal to go part of the flight. You grab that flight plan, you take a look at it, and you want to make sure that it's a legal flight plan, that it's going to be legal. So the items that you need to know in order to know whether it's going to be legal or not is you need to take a look at whatever the city pair is. Okay, so let's say it's Salt Lake to Seattle. Okay, you need to know, in order to know whether it's legal or not, you have to come up with an estimated time of arrival that you know how long is this flight going to take to operate. Now, that doesn't mean you need to go and figure out your whole route of flight and all of that stuff, because obviously that's what we do later on. That's what we're doing for the rest of the flight plan. But you need to just quickly be able to determine, okay, more or less, just a rough estimate, how long is this flight going to take to operate, just as a rough estimate. And the way we do that, I think Garrett has probably shown you already, but you get on SkyVector, or if you're using the physical maps, and you can just measure direct from origin to destination. And you just get how many miles is that from, just as if you were going to take off and point that plane directly at, without flying a route or anything, just the direct route. How many miles is this flight on a direct path? Okay, and then you take that number and you want to pad that number by, I usually like to say 15%. And that's just to kind of give you a little bit extra room to work with. But let's say 15%. And so let's say, just let me get an example up here. I'm going to bring up SkyVector.
Hey, real quick, Adam. Garrett had us doing 10%. Does it matter 10%, 15%? Do you want us to do 15 when we're working with you today?
It doesn't necessarily matter. Like, it's that one part of it is not going to change whether or not it's not going to make it make it or break it either way. I like to do 15% just to kind of be a little bit safer, but it doesn't, like I said, it doesn't really it doesn't matter. I mean, if you're used to doing 10, then you can do 10, and we can, if you guys have already been doing 10, then we'll just stay with 10. But just as an example, just in case anybody doesn't know how to do this, all you're doing here is just clicking on this flight plan and just saying, like, let's say if we were going Salt Lake to Seattle, okay, you just type in Salt Lake, Seattle, and it brings it up right there. You see that 598 nautical miles. Okay, so if you pad that by 10%, oops, made that, oh, that thing's hiding it. Let's see. Okay, if you pad that by 10%, and obviously most people can just do this in their head, but just for the sake of showing it, you just take 598 and times it by 1.10. And now that becomes 650. We'll just round that to 658. Okay, so that's padded now. So take that 658 and we're going to divide that by 400. And that should be your estimated time en route, more or less. And like I said, depending on winds and other things like that, it might end up changing. You do have to kind of keep a conscious effort in your mind about what you estimate as an ETA. And if you end up going through the flight plan process and start realizing, okay, I've got a crazy tailwind or I've got a crazy headwind on this flight, and it's going to really change that a lot, then you can come back and readdress this. But just simply for the purpose of being able to hurry and grab, just like I said, going back to the first 20 to 30 minutes of this flight plan of starting out, you need to hurry and just take a look and grab an estimate. This works for that, okay? So don't take it necessarily for more than what it is, because it's just simply to help you kind of get an idea, ballpark figure about what my ETA is going to be into Seattle. Okay, so 1.645 is what we're going to. So it should take 1.645 hours to get to Seattle. Now, was Garrett having you guys type in the speed right here up in this box?
He was having us all. He said that it's most likely to always be, or we always do 400. That's what he said.
Okay, so
I don't remember him having us type that in there.
Okay, so what
he was not.
He was not.
He was, yes.
Okay, so take a look here real quick. So I put in 400. You guys see that? You see what it tells me my estimated time en route is if I do that?
Mm-hmm.
2 hours and 3 minutes. Now, why do you think that differs so much from the number I just got on my calculator?
SkyVector's using winds aloft for that particular day, so you might have crazy winds and temperatures.
Exactly. The other thing about this, when I type in that 400 speed, that's calculating it at ground level as well. Because you see this next box over is altitude. And so unless you type in an altitude, like watch this. I'll change this altitude. Let's say we fly this route at 36,000 feet, okay? Now watch that ETE. Just changed down to an hour 37. So what does that lead you to believe? Does anybody want to take a quick stab at that? Obviously, it's going to be along the lines as Greg was just saying. It has everything to do with the wind, but there is one other factor that this is also calculating here.
So temperature as well.
Yeah, temperatures, winds, but the other big factor too is
runs better at the higher altitudes, right?
Exactly. So see this speed of 400? If 400 is my true airspeed, okay? 400. So this speed here that this is using, that is not ground speed. That is true airspeed. And does anybody know the difference between true airspeed and ground speed?
Um, ground speed is the speed that it shows off the ground, and true airspeed in when as you get higher each altitude, you start to your knots start to appear slower, but you're going faster on the off the ground. If that makes any sense.
Yeah, well, it does. So
You're a feather in the wind, so if headwind, tailwind greatly affects the ground speed.
exactly. So yeah. So you're gonna and you've probably already been seeing this, but there's a lot of different speed elements to flying. There's true airspeed, there's indicated airspeed, and there's ground speed. Those are the three big ones. So ground speed is the one that we need to use in this class. We use true airspeed and we use indicated airspeed, but those are based more on power settings and obviously flight level configuration. So the big difference here is that what I'm ultimately telling you guys is that it's best to actually not use this speed or this altitude here. The only thing that you guys want to use Sky Vector for is just simply use it only for getting your route of flight down, and that's it. The only thing that Sky Vector helps us with is that it automatically adds up our distance. It just makes it a little bit easier to, because we can type it all in and get the coordinates, and it'll do all of our math for us. But at the end of the day, like if you needed to take out a paper chart and use it, you're technically doing the exact same thing you're doing on Sky Vector. The only difference is that it takes longer on a paper chart, obviously, because you have to manually add everything up. But when it's just like Greg was saying, Sky Vector does use winds, and it's the current winds out there. So the thing is none of you guys are ever going to have a flight plan packet that's going to be based off of current weather. So that's why it's important to not use the speed or the altitude function on Sky Vector, because it's going to be using a wind element in there that may be totally different than the wind that you're going to have in your flight plan packet. So take the 400. Always do the calculation just on your own calculator manually outside of Sky Vector. Okay, is everybody good with that?
Yeah.
So, Adam, when we do our practical, when we have to do it on the charts, the paper charts, like how much do you think it'll take us? I mean, I know it'll take us longer, but it's not going to take us like 20 minutes longer, right? Because we can't use Sky Vector to get that estimate in our exam.
Yeah, so in that case, what you would do is the paper charts have, so you'll have a ruler, and you guys will see all of this next week because we'll have all of this stuff in class. So we have a flight planning, like a little scale thing that you will use on the map, and all you're going to do is you're just going to take, it's like a ruler, okay, that has distance on it, and you take that ruler and you just simply set it, like you're just measuring the straight distance between Salt Lake and Seattle or whatever two cities you have. And all you're going to do is take the ruler and just add it up on that. But, the ruler itself is like 500 miles long, because it's to scale for the map. So,
Okay.
So in other words, to find the direct distance between two cities using the ruler and the map would take you maybe 5 to 10 seconds.
Okay.
So yeah,
Okay.
not quite as fast as, on Sky Vector we can get it in about 2 seconds, and using a map and a ruler, if you have it all out, and ready to go, it might take 5 to 10 seconds. Just you might have to move the ruler twice just to get the full distance. But other than that, that's how you're going to get your direct distance. And once you get that direct distance, you want to manually calculate that, whether it be on your phone or a calculator or whatever. You just want to take that distance, pad it by 10%, and divide it by 400. So yeah, so just make sure make sure we just don't use these functions here, because it will throw you off. Oops. Okay. All right. So, I mean, you can see even now, like that thing just changes around a lot. Now it's showing 4 hours and 56 minutes. So, yeah, that's why we don't use it, because it's using weather elements that are not pertinent to our flight. So, anyway, so you want to get that direct distance. Hurry and figure out your ETA. The one that we came up with was what, 1.645. Is everybody comfortable in here converting a number like this into time? So if I have, and the reason I ask this, I know it's one of those basic math equations, but I'll be honest with you guys. I mean, I've been teaching this class for years, and this happens. In every single class, we have people that struggle with converting a decimal like this over to minutes, and going back and forth between minutes and time, and converting those things around. So if it's going to take me 1.645 hours to fly from Salt Lake to Seattle as a rough estimate, how long is that in minutes? Somebody just figure it out real quick for me and throw it out there.
1:36.
1 hour, 36 minutes?
Yeah, I times that by, I'm the one, I struggle with that big time, so I times that by 0.6, and I get the minutes.
So you take this as it is right here, right? And you times it by 0.6. So that's your total minutes right there, right?
Yeah, and then I know it's the long way, but then I take 60. I know it's 98 minutes, and then I take 60 minutes, so it's an hour and 38 minutes.
Yeah.
If there's an easier way, I'd love to know.
The 1.6, if you just multiply it times 60, it gives you the 98.7 instead of 0.987, if that's less confusing.
Yeah, you can do that too. So if you have 1.645 and you just times it by 60, you get 98.7 minutes. Okay, so now everyone should know that they're 60 minutes in an hour. So you just minus 60 off of that. You got to remember that you still took away an hour. So now you're 38.7 minutes. So now you've got 1 hour, 38.7 minutes. Is everybody comfortable with that?
Yeah. The way I do it is kind of like that. It's I take the distance divided by the speed times 60, and that's what I get.
So say that again. The distance.
The distance divided by the speed times 60, and then I'll get 98.7 or whatever it was before. And then I'll just subtract 60 every time.
So basically what I just did.
Yeah.
Okay.
Yeah. Because
there are a lot of different ways to figure out to convert a decimal over to time. So sometimes people will get lost, and it's not because it's hard to do. It's just because they end up hearing 5 different ways to do it, and that's what ends up making it confusing. So, but we're going to be doing this a lot. You convert decimals to time at several different points throughout one single flight plan. So, anyway, let's just kind of keep that in mind. So anyway, so the big thing about SkyVector is that, and so one other thing that's very, very common is that we sit here and we use SkyVector in class, and it makes people feel uncomfortable thinking that they're going to have to use a paper chart to do the actual flight plan. I can tell you right now that that is just simply it's kind of just a myth in your head at this point. And you're going to see the paper charts next week, and we can even do some flight plans using the paper charts. But the thing is that if you think about it this way, is you're looking at you're just looking at an electronic copy of the paper charts. That's all we have here with SkyVector. We're not using any of the other functions in SkyVector other than just simply the tool that adds up the route. Okay, so really the only difference between using SkyVector and using a paper chart is just simply it takes longer to use the paper chart because you have to open up the chart, and it's going to, in a lot of cases, it's going to take 1 or 2 or 3 charts, depending on what your route is, to actually get the full thing in front of you, and then just manually finding your route and adding up the distances. That is the only thing SkyVector is doing for us, is just that it's adding up the distance. And so I don't really worry about it too much. I trust that everybody can do addition, and because that's all it ends up being, is just really adding up stuff. If you can find a route on SkyVector, then you can find a route using the paper charts. There is no difference, really. You're doing the exact same process of finding a jet route, finding VORs, finding your SID and your star transition points. It all, the only difference is that you're, instead of not looking at it on the computer, you're looking at it on a piece of paper, and that's it. So, but you'll feel more comfortable with that as well next week when we'll go all paper on one of our flight plans, and you can see the process. But in total, a flight plan that you do on SkyVector as compared to one that you do with just paper charts, it'll take you 10 to 15 minutes longer to use the paper charts than it will on SkyVector. But other than that, that's the only thing we even use SkyVector for. So the rest of the flight plan is all being done manually anyway. We never even look back or reference it really for anything else. So anyway, so all I'm really saying with that is that don't worry about that too much, because it's really, once you actually take the practical flight plan test, you'll come away saying, yeah, actually that wasn't as bad as I thought. That's what every single person tells me. So okay, but getting back on track here real quick, just going back to this whole philosophy of what do we need to figure out in the first 20 to 30 minutes. Okay, so we've got this distance here. Now we've got this 1 hour, 38.7 minutes. That's your ETA. So now you have something to go off of here. You have this time element that you can take a look at the TAF for your destination. So on the flight plan, it gives you an estimated time of departure. So you already know your ETD. You know what time you're leaving. So now take that information, take out the TAF for the destination, and look it up. So you're gonna plug in, okay, well, if I'm leaving at 1930 Zulu from Salt Lake City, and it's going to take me 1 hour, 38.7 minutes to fly to Seattle, my ETA into Seattle should be roughly 2109, 2108, 2109 Zulu, if I add that 1 hour, 38.7 minutes. So when you take a look at that, see where that falls. See what the weather's looking like at the destination at that time frame. Now, keep in mind that this is just a rough estimate. That you're yeah.
What was that ETD and where did you get that from?
Okay, hold on. There was a couple of you guys all talking at the same time there. Was that so, Corey?
What was the ETD and where did you get that from?
The ETD will be given to you on your flight plan. Is that what
I'm sorry, did you what's the one you were using? Were you just using one?
Oh, I just made up one. I just said, okay. I said, if your ETD is 1930 Zulu, that's, the ETD will always be listed in big, bold letters right at the top of your flight plan packet. So you'll know that that's given to you. So
Right. That's why I was asking, because I know it usually comes on.
Okay, so I just made one up just for the example purpose here. 1930 Zulu is what I was saying. Like, okay, so if our ETD out of Salt Lake City is 1930 Zulu, and it's going to take us an hour and 38 minutes to fly to Seattle, our ETA into Seattle, now the ETA you have to figure out, but if we're using the rough estimate here, an hour and 38 minutes that we came up with, that makes your ETA into Seattle 2108, right? 2109. Somewhere right there. Now, the only reason you want this is so that you can take that ETA and plug it in to the TAF for Seattle. So you're looking at Seattle's TAF now, and in fact, we'll just bring it up. Like I said, we're gonna start fresh on one here in just a few minutes, so we'll go over this again. But so if you're looking at the TAF for Seattle, and that, if the 2100 time frame looks good, then that's going to answer a lot of your questions right there. Now, the only thing when you do a rough estimate on your ETA, now, like this is kind of the part that I was getting to just a few minutes ago, you have to keep in mind that it is a rough estimate. If you're looking at the TAF for Seattle and you have really sketchy weather, like really close to your ETA, let's say your ETA of 2108 is fine, but 30 minutes earlier or 30 minutes later, you have really crappy weather, then you may want to second guess your ETA. I mean, it could be possible that that once you actually go through and do the flight plan and get real numbers, that your ETA would fall either in 30 minutes earlier or 30 minutes later. So that's the only time you need to be a little worried about using a rough estimate. But if your rough estimate is 2108 and the nearest crappy weather is like 5 hours later, I can promise you that your rough estimate isn't going to be that far off that you would need to worry that it would fall into a section where it might not be legal. So you're using this rough estimate to determine if the flight is legal to go from the weather perspective. Okay, so you want to take a look at that. You want to make that determination. And with that example that I was just giving you about, if you have crappy weather that's within 30 minutes plus or minus of the rough estimate that you came up with, you're typically not ever going to really see that. It's usually going to be pretty cut and dry. Like, is it legal? Is it not legal? It's either not going to be legal at your ETA or it will be legal at your ETA without any usual hint of being illegal, plus or minus 30 minutes from the window of plus or minus 30 minutes. So I don't want to make you guys think that you're going to be dealing with that, because you really won't. But so anyway, you make that determination of the weather legality. You take a look at your MELs. If you have an MEL, let's say for no icing or something like that, you go and you look up the MEL and it says aircraft cannot be operated into known or forecasted icing conditions. and you take a look at your weather, you have to make that determination. But sometimes an MEL like that, like, if you're in the middle of even this time of year right now, this time of year and really any time of year, it is very difficult to ever operate a plane that has like a no icing MEL, or a plane that has, let's say, a like a weather radar MEL. Like a weather radar restriction would be that you can't fly in or near thunderstorm or hazardous weather. And you're flying in the middle of summer and there's thunderstorms all around, and you're going to get this practice. So as far as MELs go, you're going to have several of those types of flight plans next week that you're going to see this kind of stuff. So you're going to get this practice of going through this. So don't worry about it too much right now as far as, when I'm talking about, oh crap, MELs and stuff. It'll all be part of the process. But all I'm really saying is that you need to just take a look at your weather, take a look at your MELs, and determine if the flight is going to be legal to operate or not. Part of also looking at that is looking at your Notams. Let's say you have a plane that has no MELs on it. Let's say that the weather is perfectly clear, both at the origin and the destination. Okay? And let's say that there just happens to be a Notam in Seattle that the entire airport is closed at your ETA. And let's say, for several hours surrounding your ETA. That still would be a situation where where the flight is not legal to go. And it had nothing to do with weather or MELs. It was a Notam that's causing it to be not legal to go. So that's obviously really rare, but what the key idea here is just that you look at all of the parameters that might make your flight not legal to go, and you have to make that determination, within the first 20 to 30 minutes. Because if in a real flight, in a real world scenario, like I should say not real world, but let's say in the actual FAA practical test scenario, if the examiner gives you a flight plan that has something that makes the flight not legal to go, he's going to be expecting to hear you raise that concern within the first 20 to 30 minutes. So if you get going along with the flight plan and you're like an hour into it and you haven't addressed the fact that the flight's not even legal to go, then it's going to be obviously a very grave concern for the examiner. Because when a flight is not legal to go, you don't dive in and start doing any other work. You have to address that concern before you start spinning your wheels, calculating all the rest of the material. So ultimately, kind of what I'm getting at here is that you do all of the hard part, all of the true dispatcher skills are, and these are the real world dispatcher skills, because as you guys know, manual flight planning, once you get done with this course, you will never manually flight plan another flight the rest of your life. So as far as the manual flight planning information can go, as soon as this course is over, you might as well just forget it, because you're not going to need it. So the reason I'm really putting an emphasis on this first 20 to 30 minutes of the flight plan is that is where the real test is. That is where everything, that's honestly where the test is passed or failed. Everything you do after you figure out this information at the very beginning is just math. That's all you're doing. So you've got this thing that takes you 3 hours, 4 hours to complete, right? That's about what it's going to take you, 3 to 4 hours to run through an entire manual flight plan. However, 3 hours and 30 minutes of that is just simply doing math. I mean, it is a combination, obviously, of looking at weather, but at the end of it, all of it is just gathering data and doing math, figuring out fuel, figuring out speed. It's all math. So,
Hey, Adam.
yeah, go ahead.
So when we go through this stuff, the biggest stumble that I have is when Garrett says, "Okay, what's next?" And I don't have a checklist in my mind of this, then this, then this, then this. Once he tells us what to do, I'm pretty good at remembering and figuring out and actually solving the problem. I've watched quite a few of these videos after the fact, and part of what there's a lot of explanation and Q&A and stuff like that. If you could do one where, like, if you go through this flight planning thing tonight, we've heard the theory behind everything before, but I think just doing the steps and saying, here's the steps, here's how you do it, here's the tools you use to get it done. If we could just go through those steps, because we know a lot of it, but it's putting it in an order.
Yeah.
And then if we had one recording here that was basically like not so much asking questions and stuff like that, but just here are the steps. They'll go through all the steps and cover all the options, because then that one would be easy to go back through and kind of go through our checklist, if you will. We're actually working on one together as a class. So does that make sense?
Yeah, that does. In fact, I have a video from previous classes that's actually like that. It's really more for the actual like flight plan and leg calculation part, which is really the steps that people are really trying to figure out most of the time. That's the part that most people have the hardest time remembering, is what chart am I using at this given time, and what chart am I using at this given time, and what those steps are. So that one will really help a lot.
That's exactly it, because I just realized last night for the first time that there's those ISA charts that have the +5, +10, +15. I mean, I know we had those, but for last night, for the first time, I realized there's some for the ascent, there's some for en route, and there's some for descent.
Yep.
Like I don't have I need a better understanding of the tools that I have and where to find things. Like, this is the tool, this is what it's used for, this is where you find it.
Exactly.
That's what I feel like that would, I think, make it click for me.
Yeah. And that video will help you a lot with that. So yeah, I made that video, I think in the very first class. So, but it'll go through all those steps. And what I'm trying to do right now is I'm trying to give you the steps for the first part, everything leading up to doing the flight plan calculation. So that's kind of what I'm trying to do right now. The big thing about all of what I'm saying, like the information that we've been talking about so far, is that what I'm trying to stress with this part of it is get it into everybody's mind that the stressful part, and I don't even want to say stressful, because just using that word will obviously cause stress, right? So it's not really what I'm saying, I guess, with the first 20 to 30 minutes, and why I'm putting so much emphasis on this part of the flight plan, is that this is where you will pass or fail, is right here. It's not on anything after that. The stuff that the examiner is going to want to see is what you do. It is really the decision you make in that first 20 to 30 minutes. That's where you will figure out every last element of what's going to happen with this entire flight. And once you have that part figured out, the rest of it is just going through the motion of gathering the data and doing the math. That's it. And that takes a long time. And there's obviously a lot of steps to that. However, the very first thing that I want you guys to get down and get familiar with and get comfortable with is that if you can get through that first 20 to 30 minutes and you're confident in the decision that you're making as far as, is the flight legal to go, from a weather perspective, from a mechanical perspective, does the flight need alternates? Are the alternates legal?
I understand. I understand that, but I understand it's 20, 30 minutes. I understand figuring out whether or not it's legal. It's just let's just talk about the steps, because I understand that part, and Garrett has talked about it a few times also, stressing this is why. I understand that. I just need to go through the steps so I can.
Yeah, we're going to. That's what we're going to start one fresh tonight, so you'll see those steps. But what I'm trying to say, all I'm trying to say right now, I'm not necessarily addressing your question right here. Is I'm still kind of going back, because your question will be addressed once we start, once we dive into one here in a few minutes. So, but I do understand what you're saying, and we'll get that. That'll be a lot better as far as what you're wanting to see. You'll be able to see that in good depth tonight. So, in addition to that other video as well that I referenced. So between those two, tonight.
Previous class.
Yeah, it's on the YouTube channel, but I'll find it and just give you the link for it. So.
Okay, perfect. Thank you.
But yeah, as far as this stuff goes, I want to address this before I address what your question is and kind of what you're talking about. The reason why I want you guys to get this part of it into your head about the first 20 to 30 minutes is because once you're through this first 20 to 30 minutes and making the decision of the legalities and the alternates and all of that stuff, your stress should completely go away at that point, because as long as you've made good decisions, the whole flight should be legal to go. Like the rest of the flight depends on what you did in that first 20 to 30 minutes and the decisions you make in the first 20 to 30 minutes. So the rest of it is all data and elements of those decisions. So that's why I'm putting all this emphasis. And like I said, and we'll go through the steps of the first 20 to 30 minutes, but I'm just wanting you guys to know that about this process ahead of time, because I think a lot of people get caught up with, the steps of all of the steps of the latter part and the bulk of the flight plan. The part that takes the longest is not that's really just your busy work. That's all it is. You will not be asked interview questions about any of that stuff. It's stuff that as soon as this class is over, you can erase immediately from your memory banks because you will never use it again. The stuff that you will use every single day as a dispatcher and every single flight that you dispatch is the stuff that you do in the first 20 to 30 minutes on every one of these flight plans that we will do manually here that you've been doing and over the next week. So that's the part that I want you guys to remember. That's the stuff where the interview questions are going to come from. That's the stuff that you're going to use on a daily basis for the rest of your lives as dispatchers. It's all that part. A dispatch, and I know a few of you guys have gone and shadowed with some, SkyWest dispatchers. A dispatch release, it can, if the conditions are right, it can take less than a minute from start to finish, to where they haven't even seen any data, like they're looking at it for the very first time, to sending the release can be under a minute sometimes. Now, in the worst scenario, it might take 5 to 10 minutes total. And that's assuming that the weather is horrible, you've got a bad MEL or something like that you're having to look up and deal with, and having to create some weird route to go around weather and all this other stuff. That's the worst case scenario, and it takes 5 to 10 minutes. So in reality, the computer does all of the work, all of the flight planning, all of the stuff that you're going to forget and will be able to forget once this class is over regarding manually figuring out fuel and wind speeds and all that stuff. I mean, you need to understand the process behind it, and that's why we do it this way in class. That's why the FAA makes you learn it this way. But you will never be in a scenario the rest of your life where you're actually having to use it as a dispatcher. So, like I said, it's the elements of making the decision of the flight being legal to go, legal to launch, the alternates being legal, having, the impact of Notams, because you will look at weather on every flight. You will look at Notams on every flight. You will look at MELs on every flight. Those are things that you're going to be doing every single day. So does that make sense? I'm using this. Hopefully, hopefully this should make you feel a little bit more comfortable.
It definitely does. Knowing the fact that that you're not going to just automatically fail if you can't figure out the whole flight plan, kind of puts the stress off my shoulders. It's just really the crucial 20 to 30 minutes that determines if you pass or fail. So that kind of puts some of the stress off a little bit.
Yeah. So if there's one area that you really want to focus on, it's just that first 20 to 30 minutes. So let's start one fresh here. Does anybody need a break, 10 minutes or so before we dive into this? Well, let's just take one anyway. We'll take a break for 10 minutes real quick here, and I'm just going to create one just from scratch here, and I'll have it ready to go by the time you guys get back from break. So yeah, I'm showing 6:40 for the time. So let's plan on 6:50 here in about 10 minutes, okay?
Okay.
All right. Talk to you guys all in 10 minutes.
Yeah. Okay.
Oh, Adam, when we go through this, is this example where you want us to print out copies of the flight plan and go along with you doing the flight plan, or you just want us to listen and take notes? And what do you want us to do on this?
You can do it either way. If you have a flight plan ready to go, like a fresh packet ready to go, then yeah, feel free to use it.
Okay.
But you don't necessarily have to. Whatever best helps you guys, honestly, in this case.
Okay, because I don't have a fresh dispatch release form. He just gives us the release form or the packet when we do a new one. He doesn't give us all blank.
Okay, well, those of you that have one, feel free to do it, and those of you that don't worry about it. I mean, but whatever best helps you, figure it out and help do it. If it's good for you to do it that way and see it that way, then I would recommend to do it that way. But it's not necessary. You don't have to if you don't want to. If you'd rather just be a spectator and ask questions, and take notes, then you can do that. Either way, it's fine with me. Okay. So, this is so I just literally created this just minutes ago. What have been the flight plans you guys have done so far? What city pairs?
Denver to Salt Lake City and somewhere to San Francisco. I think it was it Salt Lake City, guys?
Maybe it was Seattle.
Oh, Seattle.
Seattle to San Fran and Denver to Salt Lake?
Yes.
Okay. All right. Everybody see the screen there? We're going to do San Diego to Portland. So, and like I say, the format that he does it and that I have it might be a little bit different, and I know he might be using some of the ones I've already had anyway, but this is a brand new one. This is probably going to be one of the only times you have current weather. This is literally current weather. So, okay, so San Diego to Portland. So, just assuming we are starting off fresh, we're starting off brand new. This packet was literally just handed to you just now, and this is the first time you're looking at it. Okay, so route briefing, San Diego, Portland. We're going to be flying aircraft 708 Sierra Kilo. We got 59 adults, 4 kids, and 105 bags, and our estimated time of departure is 0030 Zulu. So midnight 30. So the very first thing we want to do, so the one thing you'll notice here, there are no MELs. Okay, we are not, this flight will not have an MEL on it. So keeping it a little bit simpler. So there are no MELs, which that's obviously nice. We don't have to go check that. So the very first thing we want to look at, okay, so we know that the estimated time of departure is 0030 Zulu. I haven't even looked at any of the weather on here so far as well, so I'm not sure if it's good or bad, but so we need to know, the very first thing we want to know here is what's the rough estimate of this flight, San Diego to Portland. So let's go back over to our trusty friend, SkyVector. I'm going to clear all of this out here. Let's see. Okay. I like to put that on the world high chart. Anyway. Okay, so I'm going to come over here, San Diego, and going to Portland. Okay. So the direct distance here, 810.4 miles. Okay. Now remember, we're not going to use any other tools on here. So we've got that 810.4 mile total distance here. Going to bring up the calculator here and quickly pad this number by 10%. Times that by 1.10. Okay, so that makes it 891.44 miles. Now, the speed that we're going to use, and the speed that you will always use when you're doing a rough estimate, is going to be 400 knots. So take that 891.44, divide it by 400, and that gives you 2.2. We're going to just round that up to a 3. So we'll call it 2.23 hours. So I'm just going to 2.23, change it to 2.23. Okay, so it's going to take us 2.23 hours. We can go back to our thing where we just times that by 60. That's going to give us our total minutes. That is 133.8 minutes. Now we know that it's the 2-hour element, so if we minus off 60, or sorry, in this case, 60 and 60 is going to be minus 120. That's going to give you 13.8. So we know it is 2 hours, and let's just round that up and call it 2 hours and 14 minutes. Okay. So far to this point, is anybody confused, lost, distracted, or wondering where we're at? Or is everybody good to go up to this point?
I'm good to go.
Just a quick question. On the last one that we did, we added a 15-minute taxi time. Do we need to add anything like that?
We do all of the taxi time stuff. We do that all on the actual flight plan. So when you now remember, we're just doing what we're doing right here is just simply to get like the rough estimate ETA, just to kind of get us through this first part. So typically when you do your actual ETA and all that other stuff, you do add in the taxi out and all the stuff later on. But for right now, we're just simply kind of going with an overall ETA. So don't worry about that right now. Once we get into those steps, we'll start putting all of that back into the equation. But it is a good question though, because that obviously can be confusing if you've been doing it before. So, but for right now, don't worry about it. We just want to have the rough estimate ETA. And the reason why I don't care about it right here is because I don't believe those 15 minutes are going to make or break whether it's a go or a no-go. Okay, so everybody good? then 2 hours and 14 minutes is our rough estimate ETA here. I'm going to go back over to our flight plan packet. Okay. As you're scrolling down, now part of the legal to go process, okay, is your weather. I mean, the primary weather you want to look at is your destination, okay? But I also don't want you to ever forget about your origin, okay? We are taking off out of San Diego. Now, if San Diego's weather was really bad, like as if it were below departure minimums, that could also cause this to be a no-go scenario. So the one thing you want to quickly look at is, what is my METAR in San Diego? Since you're already there anyway and you're starting to look at weather, you want to know what it is. So right now in San Diego, we have the wind out of 270, 10 knots, gusting to 17 knots. Visibility 10 statute miles. Scattered 3,300. Broken 4,500. Anybody see any issues with that weather, or does it look pretty good?
Looks good.
Okay. Yeah, I'm not concerned about that weather. That weather is not going to be illegal to depart in. Okay. While you're there, you've got San Diego's Notams right in front of you. Take a look at that real quick. If anything stands out to you, then we can look at that. Now, we've been teaching you guys this method of being able to scan through the Notams. So the column that we scan is this column right here. That's where your eyes should be focused. Now, obviously, there's a lot of those key words that we look for are in here, okay, which is going to make you stop. So if we're looking here, runway 927 closed Monday through Saturday from 7 Zulu to 12 Zulu. Okay, so is this, we know that our ETD is 0030 Zulu, so this obviously is not going to affect us. The next one, the nav ILS runway 9 out of service daily from that same time. Okay, well, that's that same time frame. Yeah, it doesn't apply to us. This next one doesn't apply to us. Doesn't apply. So you can kind of start eliminating all of these Notams. The next one down, I mean, all of these have these time frames on them that are not even in the window of what our ETD is. So no issues with any of those. Keep going down. Taxiway, we don't care about that. Runway, that's a runway threshold. Out of service, let's see. Zone lights, okay. Touchdown zone lights are out of service. Not a big deal. Are we landing in San Diego? No, we're taking off in San Diego. So that's not going to bother us. So quickly look through all those Notams and you'll see there's not a single Notam in there that affects us in San Diego. The only thing that you guys are really looking for is making sure the airport's not closed, because the weather's great in San Diego. The only other thing that might keep us from departing is the airport being closed. So no issues. San Diego only has one runway configuration, so if you had that runway closed, that also would be the equivalent of the airport being closed, since it's the only runway. Okay. So moving along here, let's go down to Portland. Okay. So if our ETD is 0030 out of San Diego and our rough estimate ETA, or estimated time en route, is going to be 2 hours and 14 minutes, that puts our ETA into Portland at 244 Zulu. Does that everyone agree with that?
Yep.
Okay, 244 Zulu. let's take a look at what our weather in Portland looks like at 2:44 Zulu. Now, we've got this from line here that starts at 3 Zulu, so that's 15 minutes after we get there, which means that our arrival is just before this line. So really the information that we're looking at, sorry, I can't draw a straight line, but that's the line that we want up there. I'm going to erase that.
How do you know which days to go off of if the tab has 2 different days on it?
Like, do you mean say
Like,
because this has a 16 right here?
Yeah, and then everything else has 17 on the fronts.
Well, you're just normally that's not really ever even a concern that you'll have because you're just simply following the time in Zulu. So the thing is right now, let me erase this stuff. Right now, so this is the current METAR right here. This is the current METAR for Portland. Okay, the timestamp on that is 23:53 Zulu. Okay, so you're not even taking off from San Diego until 00:30 Zulu, which you know is going to be the next day. So you're not even taking off until the 17th. So.
Okay,
and then you can see the rest of these are all 17 here. So anyway, so the line that you want to be looking at is that top line, and you also, because it's so close, I mean this next line here is starts at 3 Zulu, and this is a rough estimate. That 2 hours and 14 minutes, that's a rough estimate. So if you know that your estimate might be off a little bit, you could easily be into this 3 Zulu category. But even if you are, is the weather of any concern to us?
No.
No. And is the weather in the... What's that?
Plus 6 miles, which is the max on a TAF, right?
Exactly. You can't get better visibility than this in a TAF. Is the weather in the top line a concern?
No.
Nope. Okay. Now, the next line down starts at 12 Zulu, this one. Is there any concern that our ETA would fall that far down? No, there's not, right? And that's 9 hours later. So even a horribly rough estimate isn't going to be that bad. So we know that the only 2 lines that we are concerned with are just the top line and maybe the second line. And both of those have great weather. Nothing that we are concerned about. This does have light rain showers in it here, but that's not a big deal. We don't have any MELs or anything that says we can't go into that. So no issues. So from a weather perspective, this flight is legal to go. Now, let's take a look at the Portland Notams. Let me erase those marks. Let's take a look at the Portland Notams here. Okay. Remember the line that we want you to focus on. Okay. So this very top one is a runway Notam, which we do care about. Okay. Runway 10 right, 28 left is closed Thursdays from 21:30 Zulu to 22:30 Zulu. Okay. So that was yesterday. So do we care about it? Today's Friday. We don't care. Okay. The next one, runway 10 left, 28 right, is closed on Tuesdays from 15 to 16 Zulu. Once again, Tuesday is 3 or 4 days away. We don't care about that. Okay. This next one is not one that we care about. Obstacles we don't care about. Taxiway, obstacles. That's it. There are no Notams in Portland that we care about. Nothing that's affecting us. Okay. So, going back to the Portland TAF once again here, we know that it's legal to go, but does it need an alternate? No, this does not need an alternate. That's one other thing that when you're looking at the destination TAF, you might as well go ahead and figure that out too. Now, one important thing to note here, and this is kind of, these are the little steps here like this, little things like this are what will help you, kind of what I was saying earlier, dumb down the flight plan a little bit, simplify it a little bit, okay? You're looking at the Portland TAF here. Do we even need to know our ETA to know if this flight plan is going to require an alternate?
No,
And why not?
because the weather is spectacular.
The entire TAF. There's not one time frame in that entire TAF that requires an alternate. Okay? So even before you even go figure out anything from fuel and everything else, just picking that up, I mean, this is, a lot of you guys are probably looking at this and saying, well, yeah, I mean, that's easy to do there. But you'll be surprised at the amount of people that don't pick up on just little tiny things like that. Okay? Knowing that you don't need an alternate for this whole flight, it changes a lot, because now you know later on, okay, well, I don't need to figure out fuel. There's a lot of extra stuff, a lot of extra calculating you got to do when you need an alternate. Now that you know you don't need one, saves you some time. So, moving along. So let's see. We've been talking for about 21 minutes since we came back from break. And I did go a little bit more in depth into explaining this. However, even with that extra explanation, it's been 21 minutes, and we have now determined that this flight is legal to go from every perspective that we can look at it.
With no alternates.
Yeah, and we also know that it doesn't need an alternate. And that's before we jump in and do anything else. Okay? Now, this obviously was an easy scenario. You're going to have others that aren't so easy, but in no way, shape, or form, even on the hardest of flight plans, it should not take you more than 20 to 30 minutes. It might on the first couple of them that you do, but once you're into the routine of doing it, and definitely by this time next week you will be, it will not. Even on the most difficult flight plan you will look at, which I can tell you this, the most difficult flight plan you will see next week is going to be 10 times harder than any flight plan you will receive as your actual FAA practical exam. We're going to go way harder in class than what you're going to see. So hopefully that makes you feel better too.
Kind of got a laugh out of that.
So anyway, so we know that this flight, it's an easy process and it shouldn't take you very long. But the thing is you need to know right from the beginning, is this flight even legal to operate? Because if it's not, you got to say something to the dispatch examiner right at that point. And that might be if it's an MEL, or if Portland's not legal. And there will be cases where you look at the TAF and maybe the flight is not legal to arrive at the ETA that you need it to. But if you delayed it like 2 hours, then it is legal, because then the weather in the TAF looks better at that point 2 hours later. There's a lot of little things like that, and we're going to go over those scenarios a lot more next week. You're going to see that stuff. But the key thing here, the key thing that I want you guys to see and know is that's what you're doing in the first 20 to 30 minutes. You're making sure that the flight is good to go and legal to operate. Okay? You're also looking at your alternates. Now, if we would have needed an alternate in this scenario, if Portland would have required an alternate, then we also would have gone and looked at the alternate. In this packet here, I also added in Seattle as a potential alternate if we needed it, and I also added in Spokane So I added 2 extra cities in here in case we needed them as alternates. Now, we don't need an alternate, but if we did need one, we would have then gone down to Seattle and taken a look at their TAF and making sure it's legal. Okay, so it would have been one more step there, but like I said, even if you're having to figure out if alternates are legals and then read the Notams for an alternate, it shouldn't, the whole process here should not take longer than 20 to 30 minutes. Okay. So now that we know that we're good to go, I'm going to go back up to the top here. Flight's legal to go. The weather looks good. We don't need an alternate. We don't have any MELs. Okay. We've got our aircraft number there that we're going to be using. We've got our load there, passenger load and bag load. So we've got some of the other information that we need to start working with. What we want to figure out now, and I need to go back in, and I haven't opened up the flight plan packet yet. Hold on one second. Let's see here. Okay, so I've got the flight plan packet open here now. And you're basically going to just start doing some of the basics of getting into the release. But let's just go back to the part that we just started and finished there, that first 20-minute thing. Any questions, comments, or concerns on that? Was everybody comfortable of everything that I went through in that 20 minutes and the speed that I went through it? Did anybody get lost or have questions or?
Oh, not at all.
Oh, that made a lot of sense.
Okay, because this is where, I don't want to move forward unless I know everybody's on the same page here. Because what we just did is literally the most important thing you do on the entire flight plan. So is everybody good? Everybody's up to speed? Nobody left in the dust here? Sounds like we've got
No,
it.
good to go.
Okay. Just want to make sure. One other thing, and if you're putting this into like a spreadsheet and making a checklist here, one thing that you want to put in big bold letters in red, writing, whatever you want to do, but make sure that while you're doing those two things, because you are figuring out legal to go and you're also figuring out if you need an alternate, but do not confuse those two elements. Okay? Make sure if there's one thing that you need to always take a step back and say, okay, I'm figuring this all out, but do not combine those two. Don't misconstrue those two steps. Don't use the rules for an alternate as the rules for legal to go, or vice versa. You just got to make sure that you do legal to go first. Okay, you treat it as its own thing. And then once you're done, if you noticed the way that I went through that, I didn't even look at the alternate. When we went to the Portland TAF and we looked through it for the legal to go element, we then went and read the Notams, and then after we read the Notams, I went back to the TAF to look for an alternate. I don't even like to do those two things at the same time. because that just makes it more possible to use, because remember, legal to go and the 1, 2, 3 rule, which is for the alternate, they have different rules with them, and they don't relate to each other. They have nothing to do with each other, and because of that, I just don't even like to do them at the same time. I like to do what I'm doing, figure out legal to go. For me, part of legal to go is looking at the Notams. So I finish the legal to go, and then I go look for the alternate. I do it completely separate. I would suggest you guys do it the same way, because it will make sure that you do not combine the two into one process, because that's where people will mess up. That's one of the big areas that, oh, well, I used, people look back on it and they're like, oh man, I used the 1, 2, 3 rule to figure out legal to go, or vice versa. So you don't want to combine those two things into one step at all. Okay, so once you've got that figured out and you know that everything's good to go, in my opinion, the rest of the whole flight plan is all downhill. It's now, the rest of it is just going through the motions, figuring out all of the busy work, and filling in all the boxes. So I like to take out my dispatch release here, and so this front page, and this is kind of where you're going to see some stuff that I do that's going to be different than Garrett. And like I said, the stuff that I do here is just simply because it works better for me. Okay, so you don't necessarily have to do things the same way I do. I just do it because it's easier for me to dumb down the rest of this flight plan by doing it in order. And this is the way that you'll also know that the flight plan is going to, that if you remembered what I said at the very beginning of tonight's class, is that I want to teach you guys ways to simplify this entire process. Okay, if you, going back to what Matt said at the very beginning, that he didn't have all the steps memorized, right now is where I want to start showing you how to use the flight plan packet to walk you through the rest of the flight plan. Okay, you don't have to go through memorizing all these steps. You're just putting extra pressure on yourself. Now you need to, there are certain things you need to know and you need to be familiar with, but if you're sitting there stressing about, oh, what do I do right now, and what do I do next, and what do I, what was, or if you forgot something and plugged it in somewhere else, then this, I'm hoping that this will start taking care of some of those things. The one thing that is most confusing is that the flight plan packet doesn't necessarily go in the order that of the steps. So the front page of the dispatch release here, what you're looking at on the screen right now, that's the last thing you do. This is the last page that you fill out. This page, for me, this page here doesn't even get touched until you are completely done with the flight plan. Okay? And like I said, I'm hoping that maybe this helps. And for some of you it will, for some of you it may not. But I don't even write anything on this page until I am 100% done with the flight plan. The reason for this is because all of the information that goes on this page is the final calculation numbers. It's not any of our initial numbers. It's not any of our estimate numbers. It's not anything before the final numbers. And this is the last step in the entire process, is filling this in. There's obvious information you could fill in. You could do the date, you could fill in the captain, and you could fill in all that stuff. But just because I use it and I recognize this sheet as my last step, I don't even touch it until I'm done. Okay.
Thank you. That helps organize it for me anyway, so I know that everything else is prerequisite to that. So
exactly, yeah. That's the way you should look at this page. This is the final numbers. This is the accurate, real information. And so a lot of people end up putting fuel numbers on here before they even have the real number calculated. And I go back and I ask, I'm like, how do you have a number right here? That's your final number. This is the number that you're given to the captain here. And yeah, you don't have that until you're totally done with the flight plan. So yeah, I don't even touch that page until I'm done. Okay? So you're going to notice that this thing kind of goes in backwards order. Okay? This map thing you may or may not use. That might be just scratch paper, depending on whether you want to use it or not. So, but it's there. So then you'll notice the next page here is the IFR flight plan. This here is the second to last page that you fill out. So, and I'm sure the process you guys have been going through, you can understand why, because this is where we calculate all of our leg segments. These are the final numbers that we do. Okay? So I'm not going to do anything on this page yet. This next one is the performance worksheet. This is where we do a lot of the simplified flight planning and a lot of the performance numbers. These are a lot of the numbers we do here are figured out before we jump into the actual IFR flight plan calculations. Now there are some boxes down here on this lower part, like the takeoff speed V1, takeoff speed VR, V2. Some of this stuff doesn't get filled in until the very end as well. So this is kind of one of those pages that you do go to and then come back to a little bit. But I'm gonna show you that as we go along though. This page, and like I said, the order doesn't stay true to like based on what I've been showing you, you might think that you just actually start from the back and work forward, but so it's not completely true. This is actually, if you want to like write on this and put like what page do you do first, this right here, what you're looking at, is the first page that I do for the flight plan process. So this is the next step for me, is right here, is figuring out our departure airport, the time of departure, the weather at departure, the runways. This is where we go through and we select what runway are we going to take off on, okay? What runway are we going to land on in Seattle, or sorry, in Portland? And this is where we do all that information. And this is what I like to do after that first 20 to 30 minutes of figuring out the legalities. This is what I jump into next. So, with that said, this is what I want to do. So, let's see here. I've got to bring up my toolbox here. Okay. So we are taking off. So I'm going to start filling in the information on this page right here. So we are taking off from San Diego. I'm going to try to zoom this in if I can here. Oh, there we go. Okay. Can everybody see that okay?
Yeah.
Okay.
Yes.
So this next box here is the scheduled time of departure. That is 0030 Zulu. Then the next line below that is the weather at our scheduled time of departure. All I do to get this is I go back to the flight plan packet and I just simply come here. I take the METAR and I copy it all the way up through the altimeter setting. I don't put the remarks in here. I just put the bare bones of the METAR. I copy that, come back, oops, wrong one. Go back to the PDF, and I paste that in there. In your case, if you're writing it, then just copy it over. I know you guys can't see that the flight plan packet though, so if you're copying it, then you'll just have to copy based on what you see me put in here. Okay. Let's see. Oh, man. Okay, I messed that up a little bit. All right. Okay, so now for San Diego, we need to jump in and go figure out what runway we are going to use to take off on. So, what is the first consideration that you guys would use to determine what runway you're going to take off on? What's the number one determining factor for runway selection?
Wind direction.
Wind direction, correct. Now, what's the wind in this case for San Diego?
270, 10 knots, gusting 17 knots.
270, 10 knots, gusting to 17. Okay. Now, let's jump in, go take a look at the San Diego Jeppesen charts. Gonna zoom in a little bit. Okay, scrolling down through here. So this is San Diego. The biggest thing that you want to come in here and look at is you want to get to the airport layout chart. Okay, so there's an overview of the San Diego airport. What are our runway options for San Diego?
27 and 9.
Okay, so which one do you think we want to use?
Runway 27.
Runway 27. Going perfectly into the wind there, right?
Mm-hmm.
Okay, runway 27. Now, remember, we've already looked at the San Diego Notams. Okay, we've already done that part. We know that there would be nothing restricting us from using runway 27. So we should be absolutely fine. We've already looked through it. We should be good to go. Okay, let's see here. So runway 27. So what we're going to look at next is we're going to keep scrolling down, and we want to see the takeoff minimum section here. So it's the very next page, and we're looking through here. Okay, we've got runway 27, as you can see right there. I'm going to get this out so I can use my highlighter. Runway 27, that's the one we're planning on using. And this is the takeoff minimum section here that we're looking at. I'm going to, for a minute here, we're going to go back to this. And I'm going to go ahead and add my information in here. We're going to use runway 27. Back here now. So we need to know what our standard takeoff minimums are, and then we're going to roll through the rest of them. But can anybody tell me what the standard takeoff minimums are for runway 27 in San Diego?
I would be wrong if I said, 2 or 3 statute miles visibility.
Well, they're right here. You're looking at them. So can anybody tell me what they are? This is the information we're looking at right here on the screen.
Would it be the 500 and a half?
So,
Can you repeat the question?
yeah.
Oh,
So if I come back here, let's just go back to this for 1 second. Okay. So I'm filling out this information right here. You see how this says standard takeoff minimums? So we're filling out this information. I already put in runway 27. Okay. The next thing we need to know are what are the standard takeoff minimums, and then after that we need to know the less than standard RVR, the less than standard visibility, and then all of these other things we're going to fill in here.
Okay.
Okay, so let's go back to this for a minute. All of that information to fill out every one of those boxes is right here. So standard takeoff minimums. What you're looking at, there's standard right there. Is this a 3 and 4 engine plane or a 1 and 2 engine plane?
1 and 2.
1 and 2. That means we're going to be
50 RVR or 1.
Okay, so what does this translate here for us? What is this saying? RVR 50 or 1? What does that mean to me?
1 mile.
1 mile? What about the RVR?
50. I need to look back at my conversion.
Okay,
5,000.
that's fine. Yeah, anybody else? 5,000 you're saying? Okay, remember RVR values. Anytime you see RVR in charts, it's always in hundreds of feet. So if it's 50, 100, that means it's 5,000. Okay, so that means RVR 5,000 or 1 statute mile. So let's go plug that in to our little chart here. So you can go, let's see, we could say RVR 50. So sometimes there's not enough room to write both of them here. I'll accept either one of them. If you wanted to even just put 1 SM, that's fine. 1 SM. That might be even a little bit easier. But if you can write small enough to write RVR 50 or 1 statute mile, that's fine too. But either way, 1 statute mile, if you wanted to put that, is fine as well. Okay, let's go back. So the next thing we're looking for is less than standard. So LTS means less than standard RVR or less than standard visibility. Now it gets a little confusing here because you don't see anything in here that says LTS. Okay, but what LTS is it's actually this column right here. It's adequate visual reference. So this is the one that you use for LTS. And this is telling us what? What RVR is that?
RVR 16 or 1 or a quarter mile.
Okay, but what's the RVR?
1,600.
1,600. Yeah, so just so you know, Matt, when you're reading RVRs, you can't just read, you can't say 16. Okay?
Always
and in case anybody here that's listening, anytime you see these values, and whether you're seeing them in a chart here or whether you're seeing them in a landing approach chart or anything else, you must say what that equals in real RVR, because you will not. It's not that you're going to get like failed over it, but like if you were saying that like in an interview and you said it wrong, they would definitely dock you. So you got to remember what you're looking at here. If it says the RVR 16, that's 1,600. 10 is 1,000. 5 means 500. Okay, so whatever these are, whatever value the number is, you add 2 zeros to it. Okay, so just remember, and when you get asked for RVR, repeat it back in the actual amount of feet. Okay. So what we're looking for here, we got RVR 16 or 1/4. So going back to this here, oops, gonna come over here. So the less than standard RVR is going to be 1600. The less than standard visibility is going to be 1/4 statute mile. Okay, now the last ones here are going to be the absolute lowest ones we can have here, which is the touchdown. These are the just pure RVR numbers here. So if you see, when you're looking at these, if you're just look for, the only one that doesn't make sense might be the less than standard because it doesn't have the LTS on the chart. But you see these ones here, you'll see the CL, the TDZ, the mid, you'll see all this stuff on the other one. Come back to this one, you see center line, you see touchdown zone, you see all these on here. So the one thing that you can see here, if you remember when we've talked about RVR before, RVR is typically reported at 3 different points along the runway: the touchdown zone, the midpoint, and the rollout. Now, not all runways are the same though. Some, and that now in the case of San Diego, it doesn't have a midpoint. It only has touchdown zone and rollout. So when this chart asks you for the touchdown zone RVR, the mid, and the rollout, you only put what you have access to. So in the case of San Diego, there's only touchdown zone and rollout. Now, what's the touchdown zone RVR?
Uh,
500.
500. And the rollout RVR?
500.
500.
Oh, sorry. Sorry, 500.
Well, you're looking at 2 different columns here. So what's the difference between these 2 columns?
That one is it's basically just saying, that has an extra like RCL, and I forget what that stands for, but it's just saying that or that or HIRL, and then this other one is just specifying what it is, if I'm making sense.
So what you're looking at here is, this is the lighting requirement for the runway. Okay, that's what these mean to us. This is so, in order for you to be able to go down to 500 RVR for your takeoff minimums, you have to have center line lights working and high intensity runway lights. Okay, center line lights and high intensity runway lights. The high intensity runway lights are the lights that are on the edges of the runway that run the full length. So in order to go down to 500, both of those have to be working. Okay, if you go one step up for just the center line, so in order to have the 1000, you need center line or runway center line markings and high intensity runway lights. So you can kind of see here, this is where this one required both the center line and the high intensity runway edge lights. This one here could be just the center line, okay, just the center line, or it could be runway center line markings. Now those are not lights, those are just markings. So that's like, those are the big stripes, like when you're driving down the freeway and you have, the stripes between the lanes. That's what runway centerline markings are. That means it doesn't have lights. Or let's say if the centerline lights were Notamed out of service, you would still have the runway centerline markings and the high intensity runway edge lights. So if you have the markings plus the edge lights, then you can go to 1000. If you have just the center line with no markings or edge lights, then you could still also do 1000. So don't get too hung up on this. I'm just really just trying to explain to you guys what that is. A lot of this stuff, like this stuff that we're doing right here for the flight plan, is not necessarily stuff that will even like your practical examiner is even going to look at. In fact, a lot of times he doesn't even look at this page at all. So don't if you're sitting here struggling thinking that some of this might be hard to understand, don't sweat it, because it's not something that will have any effect on the outcome of whether you pass or fail. Okay, so 500 on the touchdown zone, 1,000, oh sorry, not the midpoint, because they don't have the midpoint, the rollout. Okay, so we're just filling in the boxes here, so we're not going to fill in that midpoint because we don't have anything for it. Okay, so that takes care of San Diego. Now, let's come up here. Our destination is, or I keep putting Seattle, but it's Portland. Portland. Our ETA is, we can go back in there and just, let's see, what did we have? 2:44. Now you remember that 2:44 time was still our estimated ETA. So we can come back and change this, because the next thing that we do after this, you guys, is we're going to go back in and we're going to figure out our real route, the route that we're actually going to file and fly. In addition to, figuring out more of our true initial ETA with that initial fuel that we do, that 4,000 for the first hour, 3,000 for the second hour. So you can come back and change this ETA. Right now, it's not really all that important to us. But let's go put what we do know as far as the weather goes. So I'm going to go back into here, and I'm going to go to Seattle. For right now, I'm just going to copy this line, that 3Z line, and plug it in here. Now, there's also a few other things that we need from this. Because the TAF doesn't give us the temperature and the altimeter setting, I'm going to put this information in here, and then I'm going to put the temperature that's in the current METAR and the altimeter setting in behind it as well. So it's 09 temperature over 06 dew point and altimeter 29.82. So I'm going to go back. Oops, wrong one. So I'm going to paste that information in, and I'm going to put the temperature 09, 06, altimeter 29.82. So I've got all that info in there now. Okay. So now we need to figure out, and you know what, one other thing here. Okay, that was Portland. All right. I know that I keep thinking Seattle in my head. I just want to make sure I copied the weather from the right TAF. Okay, so we're going to go to Portland. We need to figure out what runway we want to land out there. Going back to runway selection, what's the most important thing? Landing into the wind, just like for takeoff, into the wind. Now, looking at our wind for Portland, it's forecasting winds variable at 3 knots. So this is going to make it pretty easy for runway selection, right? Does everyone?
Yeah, I was just gonna say if it's a variable, then it means wind's calm mostly, right?
Yeah. So
Okay.
Not going to be a real issue for runway selection.
Variable winds are always 3 knots or less, right?
Yes. I think it's anything less than 5.
Okay.
So I'm going to bring up Portland. So with with wind being the most, the number one selection factor for runways, when wind is not a problem, like in this case, what would be the next set of criteria that we would use for runway selection when wind is not an issue?
Just for departure and arrival.
Yeah.
Just kind of segues.
Yeah. Now, a lot of airports have specific runways they like to use for just arriving air traffic and only departing air traffic, and that's not stuff that you're necessarily going to be familiar with right now. So, so for our case, now as you start dispatching more and more, you'll start kind of getting into the groove of understanding what what each airport does individually for their departures and arrivals. But for our case, just assuming that we have every runway available to us, and there's not a specific instruction for landing and departing aircraft, what would be the next thing that you would want to use with determining what one we want to land on?
Maybe the direction of just flying into the general area.
Yeah, no, that's a good one. I mean, like, yeah, if you're approaching from the south, maybe the one that is going to be the easiest that you don't, I mean, because if it was a straight north-south runway, you wouldn't want to have to fly past the airport just to turn around and land south, right? Kind of like the case is
Right.
with Salt Lake City. Like when you fly from St. George to Salt Lake City. Yeah, you always like it when the winds are out of the south so that you can land north, right? So yeah, that's one thing.
So runway length and
yeah,
approach.
Yeah, exactly. Like I like to go off. So when I have all runways available to me, now once again, we've already looked at Portland's Notams. There were no issues, so we know that there's nothing that's being excluded from our availability of runways here. So yeah, I would say the length of the runway and the approach availability. Those would be easily the next two greatest selection criteria when wind is not a factor. So just looking at this here, what runway would that be?
Sorry, repeat the question.
Just looking at the chart here and basing it off of the longest runway and the one that looks like it might have the best approach. And approach meaning instrument approach procedure if you needed one. Now the weather's good. We don't plan on even needing an instrument approach, but in case you did. What's just the longest runway you see here?
And certainly it's 28 left, 10 right, depending on which direction, because you have ILS holdings, you have the lighting, and you have the length.
Exactly, yeah. Now, when looking at an airport overview chart like this, one thing, just in case Garrett didn't teach you guys, when you're looking at these, one thing to look at is you see, like, if you see this small runway over here, you notice how, well, let's take a look at runway 10 right first. So this is 10 right. See this big lighting system that comes off of the end of 10 right? Typically, when you see a lighting system like that, that means that it's going to have it's probably the runway that has the best instrument approach available to it, like either the Category 1 ILS or better, maybe Category 2, Category 3, which we don't use those in this class, but we do use Category 1. So when you look at like this end of runway 3, you don't see any lights. Okay, that means there are no approach lights to runway 3. You look at runway, the end of 10 left, you see some lights, but they're just kind of a smaller set of lights, which means, there probably is an approach there, an instrument approach, but it's definitely not as good as the ones you see over here on 10 right. Okay. Looking down at the other end, 28 left, you see, once again, you see some nice lights here, but they're not as good as 10 right. And the same thing with 28 right. You see basically the same ones as you have on 28 left. So out of all those runways there, 10 right is the one that looks like it's the best one as far as an approach goes. It's also the longest runway, 11,000 feet. So now I don't want to confuse you guys. I mean, people can make this out to be a lot more than it really is. And honestly, the true, when you're going into an airport that has good weather, a lot of the times the runway that you select, that you put as the one to land on, 8 times out of 10, it's not even going to be the one they get assigned. So I don't want to turn this into something that it's not, because a lot of people can get, wrapped around the axles, going over this stuff and making it a lot more than it is. But the only thing that I just wanted to show you guys that, just simply to, when you're looking at an airport chart like this, that you can make a quicker decision without having to jump down into the approach plates to go look at which one has the best approach. You can usually identify it just by looking at the lighting configuration. So that was really the only purpose in showing you guys any of that. Now, for our purposes, honestly, it doesn't matter. If you select 28 right, 10 left, or 28 left, 10 right, it doesn't matter. But just for our purposes, because this one is the long one, 11,000, we'll just plan it being that one. And we'll just plan on landing on the 28 left side, because that one will be more in line with, approaching from the south. So, but just so you guys know, though, as far as the class goes, when the winds are calm like that, I don't care. If you select 10 right, 10 left, 28 right, 28 left, it doesn't matter. As long as it's legal to land on, even if, we chose 28 left just because it's more convenient from flying up from the south and because it's the longest. But if you chose 10 right and, as long as it's legal, you're not going to get docked. So the only times you need to look at stuff is when it's illegal. So if we had a wind, if the wind in Portland was saying 280, 15 gusting to 20, would it be appropriate to land on 10 right? Would it be legal to land on 10 right? So this is the reason I'm pointing it out. Okay, now in this case, we have calm wind, so it doesn't matter. So I wouldn't really care what runway you select. But if you have a tailwind greater than 10 knots and you select a runway that would be landing with a tailwind that's greater than 10 knots, then that would be something that would be marked up, saying, why did you do that? Our max tailwind is 10 knots. So if you have wind that's over 10 knots, you definitely don't want to pick a runway that's going to be a tailwind of greater than 10 knots. So that's really the only thing that you need to concern yourself with when it comes to runway selection. So we're going to say 28 left. Go back to our sheet here. Down here. 28 left. Okay. This next stuff that it's asking here is, it's asking us if the runway is grooved and if it will have a headwind or a tailwind at our ETA. Now, the winds were variable, so it's neither a headwind or a tailwind. We're not going to put that in there when the winds are variable. But let's go back and we're going to scroll down and go find runway 28 left here. Let's go back up. Just in case anybody forgot where to find whether a runway is grooved or not, you find it on that same page that has the takeoff minimums. So here's the runway information. This is for runway 3 and 21. This is 10 right, 28 left. Okay, so here's 28 left. This is going to tell us what lighting it has. It has high intensity runway lights, has centerline lights. It has a Mauser approach light system. And then over here, you can see it says grooved, and it also has RVR available. But anyway, grooved is the thing we're looking for. So let's go back to this. So we're going to say that it is grooved. We're going to put, oops, come on. Grooved is yes. And I'm just going to put VRB as the wind. For instrument approach, let's go back to our charts again. We're going to scroll down. We got to get through all the SIDS and stars here. So basically what I'm looking here, I want to look to see what instrument approaches 28 left has. Zoom out for a minute. Okay, so there's 28 right. So that's the overview chart for 28 left. So I want to actually go down. So that's ILS or localizer runway 10 left. ILS or localizer runway 10 right. Localizer DME runway 21. So there's ILS or localizer 28 left. That's probably what I'm looking for. Okay. ILS, localizer 28 left. Let's go down to the bottom. And what are the minimums for the ILS approach to 28 left?
300 and a half.
Yep, 300 feet on the ceiling. I'm getting that from right here, 283. You got to round that up to the nearest 100. That's going to be 300. And then you got 2400 RVR or half mile. So going back to our chart. Okay, so it has an ILS. Okay, one thing that I forgot to get was the frequency. Okay, if you go back up to the top, you can get the frequency right there. It's 110.5. So come back in here, 110.5. The visibility, you can put 24 or 1/2 right there if you want. Or you could just put 1/2 statute mile. That would have worked too. And then Notams, it's asking us if there's any Notams on that runway. We already looked at Notams. There's nothing affecting it, so we can just leave it. So now, as far as this page goes, we are finished with this page. So the box on the left here is for the origin airport information. Box 3 is for the destination airport and runway information. So box 2 down here is if we needed a takeoff alternate, and box 4 is if we needed a destination alternate. Now we don't need either of those, so in this case we're not going to fill in these two boxes because we don't have a destination alternate or a takeoff alternate. So that ultimately means that we are done with this page. Okay, from here I like to go back into SkyVector and I like to go figure out the route that we're going to fly. But let's give you guys a break here. So show 8:05. Let's give you guys a what do you guys want? 15 minutes? You guys tell me if you need longer than that, speak up.
I was thinking maybe I could do a break.
Garrett has you guys trained on these dinner breaks, doesn't he? Yeah, whatever's fine. If you guys, what do you guys normally do for dinner break?
I think it's about 25 to 30 minutes.
Okay, is that what you guys want? You guys tell me. It's your guys' time here. So You tell me what you want, and whatever the consensus is, I'm fine with that. Anybody but Matt.
Yeah, that's what it's.
I know what Matt wants.
I personally don't need that much time, but
Okay.
And I don't necessarily either, but I could do whatever works for everyone else.
Okay.
Let's just say 20, I guess.
Okay. All right. Sierra, haven't heard much of Sierra tonight. Is your microphone not working? See a lot of typing. Oh no, Mike. Okay, good deal. We'll plan on 20 minutes. So 8:25. See you guys back on here in a few.
Sounds good.
Okay.
I got 20 minutes. Wait, I have 20 minutes for dinner. I have 20 minutes.
What?
No, I have a dinner break. Adam, where are you staying when you come into town?
At Town Place Suites.
Oh my God, that's where I'm gonna be too. I'm gonna bug you.
Oh yeah, cool. The one right there by. I guess there is only one, huh? So, yeah, right there, right off of River Road, right?
Yep.
Yep. Yep. That is where I will be. I'm a Marriott points guy, so. I feel like I can't escape Marriott. It was, I think, the last 40 days in a Marriott, and then next week in a Marriott, and then I go right back to Oklahoma City into the Marriott again. I spend like, out of the next like 6 months, I think I spend like 100 nights or more in a Marriott. So, kind of my second
Wow.
home.
Yeah, that should give you a free a hotel stay in Hawaii.
Yeah.
At Kualina.
Yeah, I love going to Koalina. Actually, my parents have a timeshare there. So,
Nice.
yeah, we've been to it several times, and it's by far one of my favorite places to go. So okay, so jumping back into the flight plan here. So the only thing we've done so far is we have gotten ourselves this direct distance, 810 nautical miles. So one thing that I like to do when you start doing the...
Hey, Adam, I'm not seeing the screen.
Oh, yeah, sorry. Thank you. Okay, there we go. So one thing that I like to do when figuring out all of the information for the flight plan, there's a couple of things that are useful, like just numbers that start becoming useful. And I do this all on like a separate scratch sheet of paper. But one thing that you can see here that we've already got is we've got this. We did this direct line distance, but part of this, it also gives us that direct heading, that 330 degrees. So that 330 degrees is going to be your average heading for the flight. Okay? Now, obviously, we're not going to be able to fly this flight as a direct route, but when we jump into the simplified flight planning process here in a little bit, that direct heading is something that we need. So put that on a little scratch sheet of paper and save it, because we're going to need it here in a little bit. Okay? 333 degrees. Okay. All right. So what do you guys know of the flight planning process? What do we know? What are we looking for? What do we know that we need for departure? And
Need the SID and stars.
exactly, we need the SID and the stars. So we know that we're taking off from San Diego. Let's jump into the Google Drive. Let's go into San Diego. Let's see what kind of options we have. Just opening the charts here, scrolling down. Okay, so that first one, that's a star. That's a star. That is a star. There is a SID right there. Let me zoom in. Okay. Okay, so this SID here is for it. So what you can see here is it's used for regardless of whether you take off on runway 27 or runway 9, you can use it, but it basically circles around and you can use it. It goes up to the Julian or over to the Imperial VOR. So we'll keep that in mind. Let's take a look and see what else we have. It's another SID. Looks like it can be used also off of runway 27 or 9. And just in case you guys wonder where I'm seeing that from, when you see the airport, highlight this. This is the airport. That's the runway. That's the San Diego runway. When you see lines coming off of the end like this and circling around, that means you can take off going that way. And if you see a line coming off the other end, that means you can take off going that way. So that's how I know that we can use this taking off going either direction. If you were to see a line only coming off of one end of that runway, then that means that that is the only direction you can use it. Okay, so just wanted to clear that up. Okay. So this one goes up and starts following north, ends up going to either the Santa Catalina VOR or the Seal Beach VOR. Okay, now remember, when you see these other VORs out here, this Oceanside and Julian, you can tell that these are not transition points because you see the dark lines, they're going up and they connect to these other VORs, but you see how these VORs just have these light gray lines? That simply means that the only reason that these VORs are on here is to be able to identify these intersections, and the same thing with the Julian VOR over here. You don't see any bold lines connecting that, so that's how you know that they're not transitions. The only transitions here, Seal Beach, Santa Catalina. So that's another one. Let's see if there's any more. Here's another SID. So now take a look at this one. Can we use this SID taking off both directions?
No.
No.
Nope. Okay, good. This one also goes to the Seal Beach or the Santa Catalina VOR. It's called the Pebble 6 departure. Okay, and that's it. So the only SIDs that we have are those three. So now we need to figure out which one is going to be the best for us. So let's go back to SkyVector. Now, another useful reason for having that direct line already drawn in here is that you can use it to see which of those transitions is going to be most along your line of flight. So I'm going to zoom in here. I'm going to start. So there's San Diego. And I'm just going to start scrolling up here and seeing if we run into any of those. So I can see the Seal Beach VOR. I'm going to see if I can scroll in a little bit more. Okay, does everyone see this Seal Beach VOR. It's right here. And then the Catalina VOR is right over here. Okay. So Seal Beach looks like it's one of the only ones. That other one we had that was an option on the first SID was the Julian VOR over here. And that seems like it's more off our route. So the one that looks like it's the best is that Seal Beach VOR that we're going to probably want to use. So going back to this, I'm going to scroll back down here. Let's see here. So this one is for takeoff on runway 27, which is what we're taking off on. And it goes to the Seal Beach VOR, which is what we want. So we'll just plan on using this Pebble 6 departure to the Seal Beach VOR. Okay, so let's go back. For right now, I'm not going to worry about typing it all in just yet. Although if you want to, you can. You can just go Pebble 6 to SLI. You can type that in if you want. It'll plug it in once you hit enter. It'll put in all the information for the SID. It'll go ahead and put it all in there. You can see how the route just changed there. Now, everything after the Seal Beach VOR is just going to still show as direct. Okay, so we've made it to the Seal Beach VOR, and from that point, now that we're at our transition point coming off of the SID, what is the next thing that we want to look for to continue our route?
Hopefully you'd kind of want to find a jet route.
Exactly. Yeah, no, that's exactly what we want. We want to find a jet route. Now, just kind of zooming out here for a minute, kind of get a little bit of a bigger picture. You can see obviously that there's that direct route. It doesn't really have any ones next to it. Like, I'm trying to just zoom out and kind of see other jet routes that we might be able to use. So when you look at Seal Beach, as far as following a jet route, what are our options? There's obviously nothing going north off of it. There is one that comes off, continuing up the shoreline here towards LA, and then there's one going back this way. Obviously, we don't want to go back towards Palm Springs. So the only other option is really to get onto this. You can see this is labeled here Jet Route 78-134-169. So if I take my path here, I'm going to just drag it down and just drop it over the top of that VOR. Once I let the right button go, it will ask me what I want to plan here. That's the Los Angeles VOR, so I just click on Plan right there. However, one thing that you have to be careful of is that sometimes it'll put in your route for you. So if we know that that's Jet 78, we can actually just type in J78 and then LAX. You can hit enter. Anyway, that should fix the route there. So we know we're going to have to follow it to there. Now, once we get onto LAX, it looks like, see this J5 that's coming off of here? That looks like one that we'll probably be able to use. So if you start following J5, it comes up here to the Lando intersection. Then it comes off of this way through the Shafter VOR. Anyway, you can keep following it. We're just going to follow it and see how far this thing goes. J5. And notice our pink line. This is that direct line that we want to try and somewhat follow. It's pretty close to J5 this whole way. So
Adam, can I interrupt with a question real quick?
yeah, go ahead.
When we were working with Garrett in class, he would have us pick a star before he would allow us to do any of the in route or jet route stuff. Do you prefer to do it this way over that?
Well, yes and no. Technically, we will need to go figure out our star transition first. However, the reason that I do it this way, and like I said, this is going to be just one of those differences between me and him that's not necessarily, one is not necessarily better than the other, but I'll just tell you the reasoning that I do it this way. I'm not necessarily figuring out the en route part of this. What I want to figure out is where, once I start getting close to Portland, if I'm following J5, where does this end up dropping me off at? Like, for instance, this Lakeview VOR. Or
you're going to use that to help pick a star then.
Exactly. Yeah. If I can find a transition point that just happens to be along J5 when I start looking at Portland, then I at least know the vicinity that I want to be in. So if you know some of the VORs that are going to be, so I'm going to zoom out here. I'm going to zoom out. So there's the end. There's Portland. If I come back down here a little bit, there's Lakeview VOR. There's Klamath VOR. There's the Deschutes VOR. There's Rogue Valley over here. So I'm just trying to get an idea of what VORs are going to be in the vicinity of where I'm at. There's the Kimberly VOR over here. Now, when I start looking at, if I have a preference, see, based on my pink line here, I would want Klamath or Lakeview. Just knowing ahead of time that that's where I'm going to be coming up. Like if I'm on J5, I'm actually going to go right through Lakeview. So if I happen to see a star that has Lakeview as a transition, then I'll already know that that's the one I want, rather than picking the star first and then connecting to it and potentially having to change my route. So
okay, that makes more sense.
So let's go take a look. But his way, I mean, it makes sense though too, because I mean, I'm the one who taught him, and I originally probably did it that way. And as I've done it over and over the years, I've probably slowly changed, like realizing that, you know, if I just looked at this first, it might actually save some time. So let's take a look at the Portland stars here.
Well, I would think that'd be even more important selecting the two endpoints if it was a close trip. Because the two might just almost connect to each other without having to pick an en route separately. Yeah. So jet route.
Let's see. Okay, so here's the first one, the Helms 5, which is a star. Now that one is a star that comes from the north, so probably not one we'll use. The Moxie 6. Okay, let's take a look at that. Moxie 6 has Klamath Falls and Rogue Valley. Now Klamath was one of the two that was pretty close, so let's just keep that in mind. We know that we have one to Klamath, so if we can't find one to Lakeview, then we know that Klamath is the next best thing, and it looks like that's going to be the case because that's the only other star. So Klamath is going to look like the one that we're going to want. So knowing that, we come back down here. So Klamath, if we're on J5, I'm going to zoom in here. Okay, so J5 is over here. Now if you look, let's see, I'm just going to go to Klamath and follow it backwards. So see this J92 that comes off of Klamath? Oops, I'm just working it backwards here. If you notice, if you follow J92 backwards here to the Mustang VOR, you can see that J5 and J92 are both come off of Mustang. That means that tells me right there that I can follow J5 from LAX all the way to Mustang. Once I'm at Mustang, I get on J92 and go to Klamath, and I connect up to the star. So that means I can finish this part of it. So J5 to FMG to J92 to LMT. and then the star was MOXEE6. That, hit enter, and it should change everything for me. Let's just retrace the route here. Let's go all the way back down to LA and make sure that it... Okay, so there's Seal Beach, end of our SID, over to LA on J78. Then following J5, let's zoom in one more level. You notice that I didn't need to type in any of these intersections because as long as it knows I'm on J5, it knows that it follows and turns at Lando, comes over here to Rancho Murrieta, Shafter VOR. So it should know all this. The one thing, though, about SkyVector is never trust it. Even though you've typed in the route and you think it'll work, always retrace your route. You need to make sure it's staying on here because if not, it's going to mess up your distance. So once it gets to Mustang...
I was just curious about... Sorry. I was just curious about those TFRs that are in effect. Sometimes so if you happen to go, if your route happens to go through one, for example, but let's say that the TFR is restricted from surface to like 18,000. So like if your route is going directly through it at like 20,000, let's say, then do you still need to require authorization from ATC to do so, or is it free, or are you free to go through it?
The only time you need clearance to go through it is if you're going to be within the restriction. So like this one right here, that's a security one. That's surface to 3,000 feet.
Oh, okay.
Okay, so that's the Los Alamitos Air Force. I don't even know what that one would be for. There's Long Beach. Yeah, I'm not sure. That might be Disneyland. Actually, right there. So
okay, I was just curious because that's something that always kind of got brought up to my mind every time I were to see TFR.
This one right here, aerial demonstration, surface to 13,000. So I don't need to get clearance unless I'm between the surface and 13,000. So I don't know does that answer the question?
It does, yes.
Okay, if you're flying over the top of it, it doesn't matter. If you're above the altitude restriction. So anyway, I'm going to follow this all the way up to Mustang and then get onto J92 over to Klamath. Okay. And then so once it's following the star, if you see it kind of go off into this blank area like this, that's fine because the stars will do that. SIDS and stars will route it like this, but you'll notice it is actually following a path here. So, okay. So Moxie 6 all the way into Portland. And I can't remember if I need to type in Portland here or not. I don't think I do. But yeah, I don't need to. It already knows. Okay. So that ends up being a total distance of 844.8. What was the total distance that we ended up coming up with? Like once we padded it by 10%? Does anybody remember? I think it was, we had 810.
890.
891.4.
892. Let's see. Times 1.10. 891.44. Yeah. Okay. So anyway, so yeah, our estimate was about 50 miles over by padding the 10%. So 844.8 is the total distance. So now you have that total distance. So you can write that down, put it in your notes because we will need it later. So 844.8. And the other thing is, now that we have that total distance, we can figure out kind of more of that initial ETA that we're using. So let's see, 844.8, and we divide that by 400. So 2.11 hours. Okay. So if we want to get the exact hours, we're going to times that by 60. That's 126.72 minutes. Now we're going to minus off 120 because of the 2 hours. So it's 2 hours, 6.7 minutes. So we'll call it 2 hours and 7 minutes is what our ETE is, estimated time en route. So if you want to jot that down, 2 hours, 7 minutes. This is all just the initial estimate here. This is the one that you're going to add that 15 minutes to, okay? That taxi out of San Diego. So add that 15 minutes, and now our even though the estimated time en route is 2 hours and 6 minutes, we add 15 to that. That's going to be 2 hours and 21 minutes. Actually, 2 hours and 7 minutes. So 2 hours and 22 minutes would be what we add into our, so we take our ETD, that very first thing that was on our packet here, the ETD. This is, so now you take this and add 2 hours and 22 minutes to that. That's going to be what we, make sure of. Now, we've already looked at the TAF. We know that it doesn't need an alternate, but just in case, this is a little bit of a better idea to go off of. So let's see, 2 hours and 22 minutes on top of that would make it 2. So it would be 2:52 Zulu would be our estimated time of arrival based on that information. Now remember, we will still figure this out and drill it down even a little bit more, and this will still be refined a little bit more later on. Okay, but the only thing that we're really using this for right now is to get our initial fuel estimate. Okay, so it was 2 hours and 7 minutes. Okay, so for our initial fuel estimate, because now that we've got our route down, the next thing that we are going to do is we're going to jump back into our flight plan packet, and we're going to scroll down to the next page, and we're going to start doing our weight and balance. Okay, but on your scratch paper, what you would want to be writing down is we got to figure out that estimated fuel. So if we know that our total time en route is 2 hours and 7 minutes, how do we figure out the estimated fuel, or the initial estimated fuel? Now this is where we use 4,000 pounds for the first hour, 3,000 pounds for the second hour. Okay, well we know we have 2 hours, so we know that first hour is 4,000. Okay, second hour, 3,000. Okay, so now we're at 7,000. And now we've got 7 minutes. So we know we're at 7,000 pounds here, so I'm going to clear that out. So how do we figure out the 7 minutes?
Do we use the 7 minutes, or do we use the 22 minutes?
So the 22 was the taxi out. So that's not necessarily our burn. We're sticking with, we use the 15 minutes to get the ETA because we have to account for taxi out time, but we don't put that into the fuel.
So to get the 7 minute part, you would take 3,000 always,
yep,
and divide that by an hour. Divide that by an hour, so 60 minutes.
Yep.
Get your 50 minutes,
okay,
and times that by 7, and then that's what you add to 7,000 pounds.
Exactly. 350 pounds is 7 minutes. So we add that to our 7,000, and that gives us a fuel burn. Now remember, this is the fuel burn, okay? This is the fuel burn, 7,350. Now remember, we're still in the initial estimate phase here. Okay, the only thing that we're using this fuel number for is weight and balance. That's the only reason we're using this. What other fuel do we have on board here in addition to the burn fuel?
Taxi, hold.
We have
Fuel.
Reserves.
Okay, how much do we use for reserve in the class?
45 minutes.
500.
Which is how much in fuel? 2,500 pounds. Okay. Okay, so that's 9,850. So that 9,850 is my burn and my reserve. Is there any other fuel that we're not accounting for? I've heard a few of you guys yell out some other ones. Now, I heard somebody say taxi out fuel. Now, remember, taxi out fuel, we do not include that in our fuel estimate. The reason why is because our weight and balance is based on the fuel that we have when we take the runway. That means the taxi out fuel would have already been burned off.
Okay.
Okay.
Got it.
Okay. So don't worry about the taxi out fuel. I heard somebody mention hold fuel. Hold fuel would be something that would be on board here if we're using it. Now, what would be the reasons we would have hold fuel?
Because if you get, for instance, or for example, if you have congested airspace, most likely you'd be in a holding pattern, and so that's what you use that fuel for, and go arounds. And
yeah. So just as a normal consideration, hold fuel. If you're going into a really busy, congested airport, you might want hold fuel. But one of the primary things that causes congestion is going to be weather. Bad weather will usually cause airplanes to have to hold due to congestion. Now, San Diego is not a congested airport. Portland is not a congested airport, just traditionally speaking. The weather. Let's think about the weather. The weather on both ends of the spectrum here, origin and destination, is great weather. I don't expect to have to hold for weather. So this is more than likely a flight plan that is not going to need hold fuel. But I do obviously want you guys always to be thinking about hold fuel, on the flight plans that do need it. This one, however, does not need it. So there's also contingency fuel, alternate fuel. Do we have an alternate? No, we don't. So there's not going to be alternate fuel. Contingency fuel is also used for reroutes and potential, delays and things like that. Does anybody know the difference between contingency and hold fuel?
no.
Anybody want to take a stab? So the difference between contingency and hold fuel.
Maybe when you get.
What's that?
Would contingency fuel just be in case of like a reroute for some reason? Like if you had to take a longer route or select a different SID or something like different star, something like that?
Yeah, it could be for anything. So holding fuel is when you expect to have to hold for weather or traffic congestion. Contingency fuel is for possible reroutes around weather, ATC reroutes, little things like that. Now, the difference between those two, it's the dispatcher who actually decides, okay, the dispatcher decides what is hold fuel and what is contingency fuel. The dispatcher is the one who classifies it either as hold or contingency. If the dispatcher classifies it as hold fuel, then the pilot has to take it with him. He has to have it on the plane. If he classifies it as contingency fuel, then it's up to the pilot's discretion. Okay? So that becomes a very important thing in the world of dispatch, is whether or not it's hold fuel or contingency fuel. And obviously that will come on the dispatch release. But if it is hold fuel, then the pilot must take it. He does not have a choice. He has to take it. If it's contingency, then it's his option to take it or leave it. Okay. Do you guys remember talking about the acronym MINTO? M-I-N-T-O?
Yes.
Okay, MINTO. MINTO is the fuel that the plane, that the aircraft must have on board right before they begin the takeoff roll. Okay, it's actually part of the takeoff checklist. Right as a plane, after a plane taxis out to the runway and right before they take the runway, the takeoff checklist, one of the items on it is that they verify that they have MINTO fuel on board. Now, MINTO stands for Minimum Fuel for Takeoff. Okay, it is a legal requirement. So whatever, the dispatcher is the one who determines the MINTO fuel. So MINTO is obviously going to be comprised of 4 different things. And it's a different acronym, but the acronym is BAR H. Has anybody heard that acronym, BAR H?
Yeah.
Okay, so BAR H is your acronym, which stands for burn off, alternate, reserve, and hold. Those are the 4 fuels that make up MINTO. Now, not all of them, you know that on every flight you're going to have burn off and you're going to have reserve, okay? Those have to be on every flight, regardless of whether it has an alternate or hold fuel or not. However, alternate and hold fuel it may be there and it may not. Obviously, if the flight requires an alternate, then it has to have the alternate fuel on board. And then the hold fuel is simply up to the dispatcher. If he wants to classify some extra fuel that he wants the pilots to take with them, and he says that it's hold fuel, then they have to take it with them. If he classifies it as contingency fuel, then they do not have to take it with them. But if it is hold fuel, then it becomes part of MINTO, which when they take the runway, it has to be on board. If they do not have MINTO fuel on the aircraft when they take the runway to begin their takeoff roll, then the flight is not legal to take off. So it's a pretty big thing. MINTO is one of the things that you'll commonly hear on a daily basis in the dispatch world. So anyway, so in this case, we have 9,850 pounds of fuel. The only things we have is our burn off and our reserve. We don't have alternate fuel because we don't need an alternate, and the flight doesn't quantify needing hold fuel. So as far as MINTO goes, this would be our MINTO fuel. Now, that's what they have to have when they take the runway, 9,850. We do add in, whoops, oh no, I just did that. We do add in an extra 250 pounds for the taxi out. The taxi out, though, is once again the 10th, so the 250 pounds, which brings it up to 10,100. That's the fuel that they need at the gate. That's the fuel that the fueler guy is going to come over and put on the plane. Okay? For weight and balance purposes, we don't really care about that extra taxi fuel, so we don't really ever put it into our numbers. So I'm going to bring it back out. 9,850, that's the fuel that's going to be on the plane when it's rolling down the runway, which is where we care about the weight and the balance. Okay? Is everybody with me to that point? Any questions? Nothing? Everybody good? Okay. All right. So going back to our passenger numbers here now. 59 adults, 4 kids, 105 bags. As far as the overall weight and balance process for you guys, how do you guys feel? So everyone, I know you guys have had, this is probably the one area where people have had more practice.
Yeah, this I'm very comfortable with.
Okay. 59 adults. Okay. So when we do this part, we obviously have to go back down and we have to figure out our seating here. Okay, so it's 59 adults and 4 kids. So I'm going to just type those numbers in here, 59, 4. Okay, so I'm just going to fill up the plane from front to back. 12, 12, 12, 12, that's 48. Okay, so we've got 63 total passengers, so that takes us to 60. And 3 kids, 3 remainders in the back there. Okay, so now I just got to get my indexes. So let's see. So zone A, 12 is negative 19.2. Come back up here. Negative 19.2. Zone B is negative 13.9 for 12 passengers.
Next one is negative 8.5.
Okay. All right. Got the next one. Negative 3.1.
Yeah.
Yeah?
I have a question. So I've kind of gotten used to putting more people in the back instead of the front. Is that okay? Like
Yeah.
I have it pretty much the same as you, except for I have the 12 and the 3 swapped.
Yeah, that's fine. Yeah, unless it specifies, okay? So when you get your route briefing package, when you get handed this, if it doesn't tell you how to load it, then you can load it however you want.
Okay.
Okay? Sometimes you'll see ones that say 59 adults, 4 kids, and then it'll say load from the back to the front, or load from the front to the back, or any other specific directions. But if it doesn't give you any specific directions, then load it however you want.
Okay.
Cool? All right, so let's go back into that. So that's 2.8, and then that last zone, what in the world? What's going on with this thing? Okay, that last one had 3 passengers, so it's going to be a 2.1. Okay. So that right there equals 63. This, just adding this all up here. So I just add it up as positive numbers. Then I just convert it, just change it to a negative. So that is negative 44.7, and that's going to be 4.9. Oh, I'll change it. And that's going to be 4.9. Okay, so I've got negative 44.7, and then I'm just going to minus the 4.9 since it's a positive on there. That's going to mean the total down here is going to be 39.8. That's my total index. Does anybody have issues or problems on this, or is everybody good with weight and balance?
I'm good.
Yeah, pretty good.
Alrighty. Okay, so we are in the winter weight category right now because it's March. We've got 59 adults. That's going to be 11,505 pounds. So I'm coming back up to here. 11,505. Okay. Got 4 kids. They're all going to weigh 87. So it'll be 348 pounds. Okay. So that means my totals are going to be 63 and plus 11,505. So 11,853. Okay. So we're using aircraft 708. So I'm going to scroll down. Need to get the information on that plane. 708 Sierra Kilo. The bow weight is 44,858 with an index of 70.7. I always forget those. So 44,858 and 70.7. So 4, 4, 8, 5, 8, and 70.7. Okay. Passengers going to be 11,008, 5, 3, and this one was a, let's see, this one was negative 39.8, correct?
I believe so, yeah.
Okay. All right. So bags, we had 105 bags. That's going to be 3,150 pounds. Put that in there, 3,150. So now once again, there was no direction on how to load the bags. So when there's no direction on that, we fill up the aft first and then the forward. 3,150 pounds will all fit in the aft since it holds 3,740. Now we just need to get that index. Cargo aft, we come down to 3,150 is a 20.9. Okay. Okay. All right, so there's no cargo in the forward. There's not an observer. So we just need to sum up everything here. Okay, so 70.7 plus 20.9, it's going to be 91.6. Then this one's just being carried down, negative 39.8. Carry it right there, negative 39.8, and I'll put it right there. So that ends up with a 51.8 on the overall index. And the overall zero fuel weight is 44858 plus 11853 plus 3,150, 5,000 or 59,861. Okay, so 59,861. Any issues with that?
No.
It's below our max zero fuel weight. So remember, the zero fuel weight cannot exceed 62,300. We're underneath that, we're fine. Okay. So let's add in our takeoff fuel. It's going to be 9,850. Okay, if we look at our chart here, 9,500 is negative 2.5, 10,000 is negative 2.3. On the fuel, I don't care which one you go with. If you want to round down or up, it doesn't matter. The fuel, because it's all in the wings, it really doesn't make any difference on your center of gravity. So I'll just round up to 10,000 and we'll call it negative 2.3. So we're going to carry our index down here. If you take that 51.8 and minus 2.3, instead of rewriting them down here, I'm just going to carry it all the way to the bottom. So 51.8 minus 2.3. So our index is 49.5, and our total weight is going to be 5961 plus 9850, 69,711. Okay. Now, cross-check that against our max takeoff weight. Max takeoff weight is 75,000 pounds. We're well underneath that. Now you just need to plot where all of this stuff goes. So we plot our zero fuel weight first, 59,861 and 51.8. So the total weight over here, 59,861, it's pretty much almost 60,000 pounds, and it's 51.8 on the index. So I'm going to put an X right there. Then I'm going to get my takeoff weight, which is basically up to 70,000 pounds, just under 70,000, at a 49.5. That's going to put, actually I like to do T for takeoff. I usually put a Z for the zero fuel weight. And then the only other thing we need to figure out is what our landing weight and index will be. So the way we figure out our landing weight is all we do is we minus the burn off fuel. Now remember, and this is kind of key here, the burn off fuel, you don't minus out all the fuel, you have to leave the reserve on board. So we take our takeoff weight, 69,711, and we minus that burn off fuel, which was, does anybody remember the burn off fuel? Wasn't it 70?
Yeah, it was
7350.
7350. Okay. 7350. So that means our landing weight should be 62,361. So I'm just going to put landing weight equals 62,361. Landing index equals, I remember, so the only fuel left on board is 2,500, right? So that's going to be a negative 1.5. So when you come up to you go back to your zero fuel weight, and you take that 51.8 and you minus 1.5 from that, that's going to be a landing index of 50.3. The reason I write it there on the bottom is just because there's not a space for it up top. So 62,361, it's going to put me right on this line in the middle here with a 50.3 index. I'm going to put it right there, and I'm going to put an L. So anyway, key point here is zero fuel weight is within center of gravity limits, takeoff weight is within center of gravity, and landing weight is within center of gravity. That's what we want. That's all that matters on the weight and balance, and we're all good. Anybody have questions on weight and balance?
No.
Okay.
Just real quick on that chart right there, where are the edges if it's not in center of gravity? How far out?
Oh, shoot. Where'd this thing go? Okay. So if you are outside if you're left of that or left of this or right of that. So as long as you're in between that. So you can be in area A on both sides here. The only thing is if you're in area A, you have to make sure you take a look at the passengers. So like what it says right here, when takeoff weight and index or zero fuel weight and index fall in area A, verify by visual inspection that the passengers are evenly distributed about each of the passenger zones. As long as that's the case, then you can go into area A. You just cannot go outside of those. So yeah, we're all right here. So
Gotcha. Thanks.
So what does the in-flight portion of the envelope mean if you're in the in-flight area? Does that mean you're still able to go, or does that mean you're still able to take off, or?
Yeah, like for instance, if you had, let's say you had it would be a really weird circumstance, but let's say you had a takeoff weight up in here, up in this area, and it somehow like went into that area and then back over. I mean, it's really, I mean, I've never ever really seen it happen. You would have to almost have it kind of be like on this right side where you might have a takeoff weight up in here or something like up here, and then it goes through that and then back into area A as it burns off fuel. So you can see here is that it starts off, this one starts off, your takeoff weight is right here, and as the plane flies, it burns fuel like this, and you end up at that point. So this represents your in-flight. That line represents flying, because you start out here, you burn off fuel, and you end up right here. So it's kind of saying that you can do that as long as the line doesn't end in the in-flight. But anyway, I really wouldn't worry too much about it. It's not even something that I can even explain very well because I don't ever see it or use it. So anyway, so moving along. Okay. All right. So we have now, we've completed, we've picked our runways, we've got our route of flight, we've got our estimated fuel, we've got ETA, we've got all those things. I'm showing it as 9:27 now. So probably a good stopping point is if do you guys feel like this has been helpful as far as getting the steps down?
Yeah.
Extremely helpful, thank you.
Definitely.
Okay, so we'll just resume on it on Monday. Obviously, I'll physically be there to help it be even a little bit better as well. So we'll just.
Adam, how close do you think you are to being done? How much longer do you think it will take you?
For the rest of this flight plan?
Yeah.
Well, for me, it would be, I don't know. I mean, maybe. I mean, just depending on on the explanation of the steps, I would say probably another 60 to 90 minutes.
Oh, okay. Yeah.
So, yeah, I mean that includes, because next thing we do here is we go into the simplified flight plan. But in order to do that, we have to start gathering a couple of more. There's a couple things that we have to gather. We have to get some temperature data, and we have to get some wind data, and then we have to get in like an average wind for the whole flight, and run some numbers, and then we use the simplified flight plan burn chart to figure all that out. So, but that's actually really that's probably a lot better to show in person. It's probably a little bit easier to show in person. But the key thing though is just kind of going back to what I was saying at the beginning. Is, I mean, there is a whole bunch of information and a whole bunch of steps, but I don't want you guys to get wrapped around the axles with all of this stuff, all of these steps. The key thing is if you focus on just looking at the flight plan packet, let it just guide you through the steps. Let it kind of just show you. If you just use that, you'll know exactly what you need to go do next. I know there's in between steps that you have to use to figure out the simplified flight plan and stuff like that, but if you can kind of just cut out some of the other stuff and kind of let the flight plan packet do a little bit of the thinking for you, it might help with that. So, and I think you'll see that as we go through a bunch more of these next week. So, any last questions or anything before I turn you guys loose for the night?
Not for me. Thank you.
Appreciate the help tonight. We'll see you Monday.
Yeah, we'll see you guys on Monday. And if you get some time over the weekend, you can go back and watch some of those the flight plans from the previous classes. It'll help a lot. And I'll send you an email with that link directly to the flight plan lay calculation video that you were asking about, Corey.
Thank you.
Perfect. Thank you.
Okay, guys, you guys have a good night, and looking forward to meeting you guys all in person.
Thank you.
All right.
Likewise,
guys.
we'll see you.
Okay, have a good night, everyone.